Hey, this is Mr. Beckstrom, and today I want to take a look at problem number 14. This is from section 2.2, and it says here, for any real number x, the floor function, or greatest integer function, is x. They have these two kind of L brackets around x, is defined to be the greatest integer less than or equal to x. And here's the graph for it. Notice it kind of looks like steps here. And then they give us a bunch of questions A through E to fill out. Now, let's kind of first of all understand what this floor function is. So let's say x is 3.2. So if we go to 3.2, so it's defined as the greatest integer less than or equal to x. So the greatest integer that's less than or equal to 3.2 would be 3, right? So if we look at 3.2 here and we go straight up, sure enough, that value is 3. And it stays 3 all the way until we get to 4. As soon as we get to 4, it jumps up to the y value of 4. And this is true for every value. So this is what the graph looks like here. So let's start answering some of these questions. So the first one, they want us to know, or they're asking us this one here, so I'm going to just write it down here. They say, what is the limit of the floor function, which looks like this, as x approaches -1 from the left. They put a little minus in the upper right when they say it's from the left. So let's go to the x value of -1, which is right here, and we're approaching from the left-hand side. So from the left-hand side, it looks like it's approaching the y value of -2. Remember, we're just seeing which y value it's approaching. So from the left, it's approaching the y value of -2. So this would be equal to -2. The next question is, and this is under A here, the next question is, what about the limit with the floor function as x approaches -1 from the right? Well, going from the right-hand side of -1 here, it looks like we're approaching the y value of -1. So that's going to equal -1. And finally, let me just go ahead and put that in here. Just a moment. Sorry. And finally, what about if we are approaching as x approaches -1 from both sides? Well, we already saw from the left it's approaching -2, and from the right it is approaching -1. So from both sides, we're going to say it does not exist, because it has to be approaching the same y value from both directions in order for there to be a limit. All right, we're going to do a couple of more of these. So let's take a look at 2. So B, we're going to look at +2. All right. So x approaches 2 from the left, and we'll also do the limit as the floor function here approaches 2 from the right. And finally, we'll look at the limit as the floor function here as x approaches 2. So we'll go to the x value 2. From the left, we're approaching the y value of 1, right? From the right, with 2, we're approaching the y value of 2. And when we're approaching the limit as the floor function as x approaches 2, that's going to be, that does not exist again because we are approaching 2 different y values from each direction. All right. Okay, now let's take a look at 2.1. So we're going to change it slightly and see if we can actually get a successful limit doing it that way. So I'm going to write it all down. So 2.1.1 from the left, the limit as x approaches 2.1 from the right, and finally the limit floor function as x approaches 2.1. All right, so we're going to go to 2.1, which is right just a little bit past 2. So it's going to be right here. Now notice that from both the left, we can actually go a little bit to the left and the right. We're both approaching the y value of 2 there. You might be thinking that it's actually 1, but we actually jump up to 2 here before we get to 2.1. So if we were to zoom in really close there, we'll actually see that from both the left and the right, we're approaching the y value of 2. So in this case, it's going to be 2, 2, and then the limit does exist as x approaches 2.1, and that is actually going to be 2. And that would actually make sense because if you think about it, and you use the floor function to evaluate 2.1, the greatest integer that is less than or equal to 2.1 is in fact 2, right? And we can actually take values just above and just below 2.1, and it is still 2. So we can approach it from both directions, because if we take 2.05, that's still 2, and if we take like 2.15, that's still 2. So we have this kind of neighborhood around 2.1, and that's going to be important as we talk about limits. All right. All right, now let's take a look at another one here. Now we're going to define, we're going to say A is an integer, and we're going to define it like this. We're going to say A is an element of integers, and we kind of do it like this. It's kind of a Z with an extra line there. So it's going to, an integer is like 1, 2, 0, -1, -2, going all the way to positive infinity, negative infinity. It does not include numbers like 0.3 or 1.3. It does not include radicals, non-perfect square radicals. It does not include imaginary numbers. It's going to be all of these, like -2, -1, 0, 1, 2. And let's try it with all integers and see what we have. So the first one we're going to look at is the limit of the floor function as x approaches a from the left, and then we're going to do the limit of the floor function as x approaches a from the right, and then finally we're going to look at the limit of the floor function as x approaches, I should have probably given myself a little bit more space there. Okay, let's do a little bit over here. The limit of the floor function as x approaches a. All right. And you might say to yourself, well, what do you mean? We don't know what the integer is. Well, we could probably tell from any integer. So let's just take a 2, for example. So let's take any integer here. So let's say we took 2. If we're approaching from the left-hand side, notice how here we look at 2, it's approaching the y value of 1. If we're looking at x equals 3, it's approaching the y value of 2. If we're looking at the x value of -2, it's approaching the y value of -3. So for whatever a value, a integer we're approaching from the left, it's approaching the y value, a minus 1, right? The y value is 1 less than whatever x value we're approaching from the left. And from the right, if we're approaching x equals 2, we're approaching the y value of 2. If we're approaching x equals -3 here, we're approaching the y value of -3. So from the right, we're actually approaching the same y value as the x value that we're approaching. So we're approaching, if we're approaching a, the x value equal to a, then the y value is also a. So here the limit is not going to exist because a is never going to equal to a minus 1. So that's going to be does not exist. So hopefully these 4 answers should at least get you going on this problem. If you have any other specific questions on this, please let me know, and have a great rest of your week. Thanks.